All right, so we can walk through the list. We can access and operate on any member of the list. We can also do some accumulation operators. So that's what we want to look at next. In the accumulation, let's look at adding the numbers from 1 to 9. So we already know how to do our loop to go from 1 to 9, right? If we want to change, if we want to go from 1 to 9, we start I at 1, and we loop until I is equal to 10. So that's this part. Well, here, let me just write it over here. So we'll say I equals 1. That's where we want to start. We'll do a while. We'll say while I is less than 10. That'll sum the numbers from 1 until 9 because the less than makes us stop just before 10. And now we can say I plus equals 1. And we know that this is going to print out, or this is going to cycle through all the values from 1 to 10. And we can put in, or 1 to 9, and we can do a print I as well. We'll do that. And if we run this, this is just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, got the print in the wrong place. It's going to go 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make this right. All right, that counted up to 10. We want it to count up to 9. It started at 2. We want it to start at 1. We just move our condition a little bit, or our print a little bit, and now we're operating correctly, right? So this is generating all the numbers from 1 to 9. So if we want to sum these, what we need to do is we need to have another variable that's the total. And we'll start out by setting total to be 0. And then instead of this print, right, instead of having the print here, we'll just say total. We'll add on the value that is in I, right? So I is going to go from 1 to 9, and every time it changes, we're going to add it into the total, right? And then we will increment it, and then at the bottom here, we will print out the total. All right, if we do that, what we'll get is well, the total of the numbers from 1 to 9 is 45, which should make sense, right? Okay. Is that what we had there? And again, we can do whatever we want in here with these values. Yeah, we can do whatever we want. So let's say we want to calculate the total CO2 levels. We can go through and do the same kind of thing, right? We'll start out by setting. Now I have to grab the CO2 levels again. I should have just left that in there. Okay, so let's say we have the CO2 levels, and for some reason we decided that from a scientific standpoint, adding up all of these concentration levels made some kind of sense. Right now, so now instead of summing I, what we want total to be equal to, well, first off, we have to look at our bounds. We want to start by accessing the 0th component. So we no longer want to start at 1, we want to start at 0. We still want to walk until we reach the end of the CO2 list. So CO2 levels. So if we walk until our variable reaches the length of the list, well, at that point, we'll have accessed, if the length of the list is 10 again, 0 through 9, we can process 9, and then we'll be done. When we reach 10, we will be out of the list, so we'll leave that right down at the bottom. And now we have to think about what we want to total. Well, we want to total this component of each of these tuples, right? So let's start, we know that the name of the list is CO2 levels. We know that I is going to walk through all the possible indices, and each one of those indices is going to return a tuple, right? So 0 will return this tuple here, and we know that what we want to add up is this concentration. This is the 0 element of the tuple. This is the 1 element of the tuple. So we can actually just hard code that in as a 1, and this should go through and print the total CO2 levels. Maybe we want to calculate an average. If we want to calculate an average, we would want to say, well, the total divided by the length, right? How many elements there are in CO2 levels. right? So the sum, the total is 3,449.6 and some change down at the end. And the average is 344.96, just about 345, which makes sense if you look at the values that are actually in there, right? So now we've kind of seen a couple of things. You know, that particular thing was we're looking at, as you go through a list, you can calculate one value from the sequence of values that you're generating. And in fact, that sequence of values can actually be one or more elements from the members of a list rather than just the index variable or the counter variable itself. Okay. And we can do more stuff with this, right? So let's say we want to count the number of CO2 values in the list that are greater than 350. Well, this walks through the entire list, right? We know that without that line in there, this is going to walk through the entire sequence of indices for the list. And we know that the level in the list is going to be in this variable CO2 levels I1. So now all we have to do is, instead of adding this level onto total, we can just say if, what am I supposed to be looking at? Greater than 350. If CO2 levels are greater than 350, right? Now that's our if conditional, our if relationship, our if condition. If that's true, we'll increment total by 1. So total is going to start out at 0. Every time we hit a value that's greater than 350, we'll increase it. We'll increase I to continue walking through the list. And in the end, we will print out total, which will be the number of elements that were above 350. Okay, and this one is saying 4. So if we look at our CO2 levels, we walk through 0, 1, 2, 3, 4, 5. Here's 1 that's above 350, 2 that's above 350, 3 that's above 350, or 4 that's above 350. Okay, so that actually is working. Another one we can do is what? Percent change in each measurement from the previous measurement year, and the years in which the CO2 levels dropped compared to previous measurements. So let's look at both of those. We want the percent change per year. So we no longer need our if. Actually, let's do the first one first. Count the number, or the second one first. Determine the years in which the CO2 level dropped compared to the previous year. Okay, so if we are at CO2 level sub I, the previous level is CO2, so I1 is, let's say I is 1, right? I1 would be this value. And if we want to see if this value is less than the previous value, then we want to say if CO2 levels sub I1 is less than CO2 levels sub, we want to go previous, so it would be I minus 1. That'll be the previous value. And again, we want to take the concentration part of that tuple. And if that's the case, then we want to say print, and then I think we just want to print out the year. And I'm going to cheat a little bit. I'll grab that, and we will print out the year. Okay, so any year in which the CO2 level for that year is less than the previous year, well, we'll print it out. And there's actually an error in this code, and I'm going to show it to you before I continue. Oh, I'm printing total still. All right. So I don't know if you guys can see the error. I'm going to give you a second to kind of look at this. We'll run this again without that 0 at the end because I wasn't doing anything with total. Right, let's look at 206, year 2006. 2006 it was 323.91. The previous entry was 2004, which is 328. 328 is greater than 323, so that's a good one. 2012, it was 361.5, and in 2011 it was 363.77, so that's a good one. Other than that, they're always higher. But what about this 2001 hanging out? Well, if we look at our list, when I comes in at 0, right, 0 references this first element. 0 minus 1 is minus 1. So now we've just wrapped around our list, and we've, instead of looking at year 2000 or the previous measurement we probably don't have, now we're comparing 2001 to the end of our list, which probably is not correct. It's not really what we want to do. So we start looking at these comparison between years. We have to be very careful that we get the year range right. It doesn't actually make sense to look at, if our list starts at 2001, it doesn't actually make sense to look at years on the other side of that. So instead of starting here, there's no predecessor for year 2001. So we don't want to start at our index of 0. We want to start at our index of 1. And if we do that, we come down to just the 2 years that actually had a real increase. So be careful with that. When you're looking ahead or you're looking behind, it's important to get your starting and your ending right. And in fact, we're going to do the same thing for this next one, which is, how much more do we have? Okay, not too much. We're in good shape. Now we want to calculate and print the percentage change in each measurement year from the previous measurement year. This time I'm going to start at 0 again, and I want to show the other thing that can happen. So we're going to compare year 2003 to 2001, and what we want to calculate is, we don't need this if statement anymore. We don't need that. We still need the I plus equals 1. On the previous question, we went backwards. I said I compared I to I minus 1. We can also do that forward. So if we want to look at the percentage change between 2003 and 2001, well, then we can say, and we're coming into our loop with I equal to 0. We can say the percentage change is, we'll call it percent. We're going to say that equals CO2 levels sub I plus 1, right? Because we're going to come in at 0, and we want to look at 1. I plus 1 minus CO2 levels sub I. So we're going to look ahead 1 and compare it to the current, right? And we're going to divide it by, so let's come back here and make sure we observe the order of operations. I think maybe I need to make this a little smaller so you guys can see it a little better. Okay. Now make sure we're obeying the order of operations. We'll divide this by, I don't know, CO2 levels sub I, comma 1. Okay, oops. I need a, not comma 1, index 1. I need a 1 in there, and I need a 1 in here. Okay, so if we look at this, when we come in, right, the first time through the loop, we'll compare this one, we'll subtract this 322.16, I plus 1, we'll subtract 320.03 from that, and then we'll divide by 320.03. And let's, I guess I can do my line continuation right here, just to show you guys that it actually does work. Hope it works. Okay? And then the next time through, we'll take, I will be 1, I plus 1 will be here, so we'll take this value and subtract this value and calculate it. And then we probably want to print out percent. And let's make it a real percent, so we'll do Let's see how that works. That may work. Huh. Well, it kind of worked. Worked for a while. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 values out. Okay, so that means that worked all the way until I was equal to 9. And when I was equal to 9, we tried to reference CO2 levels sub 10, which doesn't exist in the list. And that gave us an error as well. So if we're going to look ahead, we have to adjust our upper bound on our loop where we're counting to take advantage of the fact that we can't let I get past 8 if we're going to be referencing I plus 1, because that would mean I plus 1 was actually the last index in the list, and that should actually work. Okay? So that's both of those problems. Let's kind of, I am not going to do this practice. We will look back on that in just a second, but I want to hit this other part first. Two more things we want to be able to work on. I told you that the while loop is much more flexible than the for loop, and it's much more flexible because we can do things. You know, this condition can be anything. So in particular, what we can do is we can predicate that condition on user input. So we're going to start out. I'm going to steal this code. Let's kind of look at what we're doing here. I'm not going to get rid of that CO2 because every time I get rid of that, I need it again. Right? So we can come in here and we're going to set up total. What we're actually going to do here is we're going to add up all the numbers that a user enters until he enters 0, until they enter 0. And when they enter 0, we're going to stop our loop. So we're going to start off by having this endFound variable. And endFound is going to be a Boolean, and endFound is going to be false, right? So we're saying that's false. Our condition is not endFound, so not false is a true. Okay? So we come in here, we can say, all the stuff that it requires me to type a lot, I'm going to steal. We're just going to ask for a question. Enter an integer or add 0 to end. And because we're not doing this on submittee, and because we assume a non-malicious user who knows what we're trying to get at, we're going to just automatically cast to integer and put it in x. And then we can say if x is not equal to 0, right? So x is not equal to 0. We want to add that to our total. So we'll say total plus equals x. Otherwise, right, if x is not equal to 0, then it's equal to 0, right? So this is the case where x is not equal to 0. Down here is the case where x equals 0. Now what we need to do is we need to progress and we need to end our while loop. So the way we end our while loop is we set our end found to be true. So now we've found our end because the user is putting in a value to signal the end of the loop. And then we can just come down here. That will end our loop. We can print total. Okay. So so let's see that in action. I'll put a 2 in, right? It's not doing what I want it to do. I'm going to start over again with the debugger, I think. Okay, so we can step through in the debugger, right? We're setting up CO2 values, which don't matter because we're not going to use those. We set our total equal to 0. We can look at total. We hit our while loop. We can look at our end found. That's false. We can look at not end found. Not end found is true, so this condition evaluates to true. We step through, we ask for an integer. I'll add a 2. Right, we can look at x. X has received our input value and we've cast it to an int. 2 is not equal to 0, so we should go down here and add 2 to x. And now that brings us to the bottom of the loop, right? All of these are indented. We only execute one of the branches of the if-else. We come back up, and found is still false because we haven't changed it. We didn't hit this else clause. We can ask for another value, right? And I'll add, I'm just going to do 0 this time because I want to end this quickly. 0 is equal to 0, so this time we hit the else. We set end found to be true. Not true is false, so now we've made our end condition false. We'll drop through and we'll just print out the total. Okay? So it's a really simple way to end input, and we can do this with more than, oops. We can do this with just more than one number, 2, 5, 9, minus 15. And now we'll put a 0 in, and it comes out to be 1. So 9 plus 5 is 14, minus 15 is minus 1, and then I had a 2 up there, so that makes it plus 1. All right, so that's just showing you ending on a different condition, and we can also end on conditions like, so we did that one. The other thing to keep in mind is this concept of multiple loops. Ifs and loops can both be nested. So let's take a look at what that might mean. If we want to print out, like let's say we're doing a pairing. So we want to take all the values of L and we want to pair them together. So we want to do 2, 2, 221, 212, 28, 25, 231, 21, 2, 21, 21, 21, 12. So we're going to make pairs. And we might want to do this if we're doing a matrix vector multiplier or something like that. We may have to generate matchings between either the same vector. This might be for an outer product, for example. So what we need to do is we need to generate the indices from 0 to 5, right? The length of L is 6, so we have to generate 0 to 5. So we're going to have our variable I. I has to generate 0 to 5, but we have to generate it twice. So J, when L is this element, we want to generate 0 through 5 again. So we'll start J off at 0, and we will print the pairs. So let's just start this. That was not, why do I always hit the, there. Okay, so now we have our L, right? And we have I as 0. Now we're going to set up J to be 0. Right? And now we'll start walking through, and L sub I, L sub 0, and J sub and L sub 0. So this should print out 2, 2. Right? And we just keep going through here. We're going to walk through all the J's, incrementing J by 1 each time until it gets to the end of the list. Right now, J is at the end of the list. J should be 5, I think. 6, sorry, 6. Yeah, it's off the end of the list. So now J's going to end. When J ends, we're going to jump down and increment I. Right? And now the thing is, we're going to start all over again. And we're going to walk J through again. So now we're taking I is equal to 1, so we're going to match L sub 21 up with all of 2, and then 21, and then 12, etc. Okay, so this is just a, you can manipulate nested loops. It's really important for a lot of mathematical operations. We'll do that a lot. And there are some things we can do with this. What happens if instead of starting j off at 0, we start j off at I, right? So the first time through, we'll hit 0, 0, but we're not going to go back. We're not going to get this 221 or 21, 2, right? We'll get, this line is going to be skipped because j is never going to be value 0 again. It's going to be, you know, this next time through when I is 1, j is going to be 1. Huh. Right, so we go through our original printing out all the values again, 2, 2, 221, 212, 28, 25, 231. Right, now we've jumped out, I is equal to 1. When we come through, we're not going to set j equal to 0. We're going to set j equal to I. So the next value that's going to be printed out is L11. So that'll be 21, 21. Right? And if we want to take this even further, right? And the next time through, so that only generates 5 things because we've shortened our list. We're not printing that first one. This time we're going to ignore the 21s. We're going to start out at 2, 2, and so on. And we can do this even farther. Let's say we don't want to print out the diagonals. We can do something like that, right? This should do this exact same thing, except it'll never print out 2, 2. It starts at 2, 21, 212, 28, 25, 231. That's the end of the first pass. The next pass through, I is equal to 1. We print out 1, 2, 1, 3, 1, 4, 1, 5. I is equal to 2. We print out 2, 3, 2, 4, 2, 5, and so on. Okay, so those are just some things you can do with loop boundaries. I think I am out of time, so I'm going to let you guys go. If you have any questions on this, we will ask. Okay, so there's some confusion on what loop condition means. This has to be something that changes, right? So, you know, we have to put in a variable. We can either put true into a variable or false into a variable. If we put true into the variable, then we have to change it to false at the end. If we put false into the variable, then we want to use the not condition and change it to 2 at the end. I can go through that a little bit more next time. But you can't use just the variables true or false because you actually need to be able to change these and make them different during the pass of the algorithm. I'm not sure I got that exactly answered correctly, but all right, we'll see you guys later. I'll stick around for a little bit if you guys have any more questions. And remember that we have a review session on Thursday during this normal time. I will tape it, but there's going to be a limited amount of time to view the tape, particularly since it takes me a bit of time to actually process it. And yes, please remember to read the PDF. Don't come to office hours before don't come to office hours or the Thursday review session without having at least looked at everything. All right? YouTube channel. I don't even know how to plug it. I put the links in. You guys got to follow the links. And I have I actually did a CS1 playlist. So I don't think it's going to make me a star, but maybe. That would be fun. Next Vsauce. My sons watch that. Along with Markiplier. They're big fans of Markiplier for some reason. If I beat PewDiePie, I'm retiring. Yeah, so the plus or minus 1, right? This J loop, right? This is this lines 13 and 14 are the body of the J. So when this loop terminates, we drop down and we increment the I loop. And then we go up to line 9 and test the I loop. So until I gets bigger than the length of L or gets equal to the length of L, we will continue executing this loop. Well, the first thing that happens is we come down and we reset J to some starting value, either 0 or I plus 1. So yeah, it just kind of keeps us in that. Okay. Thanks, Kristen, for taking notes again. And answering many of the questions. Good job. You're welcome.